All right, guys, so let's see how long we take. The first thing we do is the unit circle. We're going to start. You see where all those little degree symbols are? That's where you put the degrees. So usually you do one really fast, and let's see, I just go here 0, 30, 45, 60, 90. What's the next one? 120, and then, perfect. 210, 225. 240, 270. Which one's this one? And there it is. And then some of you are leaving that one blank for some reason, but that's fine. I didn't take points off. And then the radians, so this one's 0, then it's pi over 6, pi over 4, pi over 3. I don't see any errors there. Then this one's pi over 2. And then this one has the same denominator, a 3, but it's 2 pi. And then this one has a 4, same denominator, but it's 3 pi. And 6. And 5 pi. Right? And we're not robots. That's because this angle here, that's pi over 6. And you're pi over 6 from 180 degrees. So if you're pi over 6 from 180 degrees, that must be 5/6 of pi. Does that make sense, guys? And we continue with that deal. This is also pi over 6 here, that reference angle. So then this has to be 7 pi over 6. And it's the same deal with this, right? So that's a 4, so 5 pi. I don't see any mistakes, but let me know. I make mistakes all the time. 4 pi. And then 3 pi over 2. And then this is a 3 as well again. But now let's see. This distance from here to here, that's pi over 3. So then that has to be 5 pi over 3 because you're... Chop, what are you talking about? That's pi over 3. So you're pi over 3 away from 2 pi. So 6 pi over 3 is 2 pi. So that's 5/3 of pi. See? 4, and then let's see, 7 pi. And then 6. So that has to be 11 pi because this gap right here is pi over 6. So you're pi over 6 away from 2 pi. And then the 2 pi, 1 revolution. I don't see any mistakes. How do we feel so far? Not bad, right? Okay, so now, oh, sorry about that, guys. It's probably my phone. Yeah, it is. So now coordinates, the easiest one are these. The radius is 1 on a unit circle, so that's 1, 0. This is 0, 1. Some of you guys mixed that up. -1, 0, 0, -1. So those are the easiest ones, guys. So please make sure those are correct. And then here we go. Square root of 3 over 2, 1/2. Square root of 2 over 2, square root of 2 over 2, and then 1/2, square root of 3 over 2. And you just make the x negative and keep the y positive. So negative square root of 3, oh, nope, negative 1/2, square root of 3 over 2, negative square root of 2 over 2, square root of 2 over 2, and negative square root of 3 over 2, 1/2. And then in quadrant 3, they're both negative. So negative square root of 3 over 2, negative 1/2, negative square root of 2 over 2, negative square root of 2 over 2, negative 1/2, negative square root of 3 over 2. And then in quadrant 4, the y is negative and the x is positive. 1/2, negative square root of 3 over 2, negative square root of 2 over 2. Oh, there I am. Square root of 2 over 2, negative square root of 2 over 2, and square root of 3 over 2, negative 1/2. Let me know. Did I make any mistakes, guys? Is everything okay? Yeah, there was almost some moments where we almost made a mistake, but thankfully we caught it really quick. How do we feel? You feel okay? Nothing crazy, right? All right, let's go to the next one. Here's what I wanted to see on this one, guys. This is similar to saying 2x squared minus 3x minus 5 equals 0. So how did you factor that when you were in Algebra 2? You factored it like this. You said there's only one way to get 2x squared, 2x and x. And there's only one way to get 5, 1 times 5. So I wanted to add up to a -3. So don't write this down because I'm going to do a wrong one on purpose. So if I do 1 and 5 there, well, 2 times 5 is 10. And 1 times x is 1. So the difference between 10x and 1x is 9x. And that's not a 9, that's a 3. So that's wrong. So then that means the 5 goes here and the 1 goes there. 2 times 1 is 2 and 5 times 1 is 5. And the difference between 5 and 2 is 3. Do you guys see that? So this is correct. And then I want the negative to be the bigger number. So put the negative here and then the positive there. So now this is correct because look, 2x times x, that's 2x squared. 2x times 1, that's a positive 2x. Negative 5 times x, that's a negative 5x. So negative 5 times positive 1, that's a negative 5. Negative 5x plus 2x is a negative 3x. Does that make sense, guys? Yeah, if you guys are having issues with factoring, please start coming in. So that means I can rewrite this as 2 sine x minus 5 and sine x plus 1. This one will never happen. Sine x will never equal 5 over 2. But this one will happen. Sine x plus 1 will equal 0. Sine x will equal negative 1. And on the unit circle, that happens down here. And that radian is 3 pi over 2. You're going to need a calculator, guys. I'm going to take out my calculator. They're over there in the corner, guys. Alright, notice this says in degrees. So here we go. It says come up with an equation using cosine and 10 as its phase displacement. So y equals a cosine b x minus c close plus d. So let's see, the midline is 8, so d equals 8. The amplitude is the gap between 8 and 3. So the A is 13 minus 8. What's that? 8. 9, 13, 8. 9, 10, 11, 12, 13, 5. And then the B is 2 pi divided by the period. The period, let's see, 38 minus 10, that's 28. So what's that? Pi over 14. I make mistakes. Oh, and it does say degrees. So this is if we would have been in radians. Notice that's a radian. I only took a point off. Look, I almost made it. Maybe I should give you back that point. If we're in degrees, instead of 2 pi, it should be 360. And 360 divided by 28. So I take my calculator. Clear. 360 divided by 28. Enter. Math, fraction, enter. 90 over 7. This one's preferred. Preferred. Because we're in degrees. And let's see, what else? The C. The C I'm going to use, well, it says use 10. So I'm going to use 10. And there it is, guys. So I got everything. Y equals, because it says Y. And let's see, the amplitude is 5. Cosine parenthesis 90 over 7. And I guess technically I should be using theta minus 10 degrees, close, plus 8. But it's okay if you use the letter X. And that's it. How do we feel? Okay. All right, next one, guys. Cosine with a phase displacement other than 10. So if I'm using cosine, I have to use a peak. So nothing changes other than the phase displacement. 90 over 7, theta minus 38 degrees, close, plus 8. And there it is. That's it. And then for the sine, it says to use sine here. So if I use sine, I have to use a point of inflection on the way up, increasing. So I'm going to write y equals 5 sine, everything else is the same, 90 over 7, theta minus 3 degrees, close, plus 8. There it is. And here we go, cosine with a negative vertical dilation. So here's where I do a different graph here in sky blue. I don't know if you guys remember. And I say, what if I wanted this equation in sky blue? Well, if I wanted this equation in sky blue with a, bless you, I would go, the green one and the blue one is the same. 5 cosine, well, but I mean same, it has the same period, same everything. Same period, same amplitude, same midline. So 90 over 7, theta minus 24 degrees, close, plus 8. Now, if I want that sky blue line to turn into the green one, all I got to do is put a 1 in the front. Yeah, put a negative. If I put a negative, that reflects across the quote-unquote x-axis, I guess the midline if you want to say, and that max turns to a min. So, what I'm trying to say is, if I want a negative, y equals negative 5 cosine 90 over 7, theta minus 24 degrees, close, plus 8. And if you put a negative, this max will turn into a min. All right, same thing with this. I want a point of inflection on the way up on the sky blue line, so I'm going to use 17. So y equals negative 5 sine 90 over 7, theta minus 17 degrees, close, plus 8. And there it is, guys. What do you guys think? Not bad, right? Okay. Here's what I wanted to see for these. And I'm going to go slow. And no yawning, that's a demerit. I'm kidding, YouTube. I'm not giving demerits out. Not for yawning, at least. I can't even remember the last time I gave a demerit. All right. You guys ready? You know what? I don't think I've ever given one. Who wants to be the first? No, it'll be like a fun one, you know? Like for yawning. I'll stop. All right. What do I do first, guys? Arc? Is that what you said? Okay. If you had that, maybe I gave you a point. I can't remember. On the unit circle, where is sine equal to 1? Pi over 2. So pi x plus pi over 5 equals pi over 2 minus 2 plus 2 pi n. And then I'm going to move the pi over 5 to the right. So pi x equals negative pi over 5 plus pi over 2 plus 2 pi n. Now you can use your calculator to get a common denominator, or you can just, I don't know, how do you want to do it? With a calculator? Without a calculator? Times 2 over 2 times 5 over 5. So it's pi x equals negative 2 pi over 10 plus 5 pi over 10 plus 2 pi n. And I'm going to move it right here. Pi x equals negative 2 pi plus 5 pi. 5 minus 2 is 3. So 3 pi over 10 plus 2 pi n. And then I'm going to divide everything by pi. Divide by pi, divide by pi, divide by pi. When I do that, x equals, the pi's cancel out. And you get 3/10 plus 2n. So there it is. So my interval is between negative 1/5 and 4/5. So my only answer is 3/10. Because if I add 2, I'll be outside the domain. If I subtract 2, I'll be outside the domain as well. What do you guys think? Okay, cool. Let the record show that we have some thumbs up. Okay. If you guys want to subscribe and thumbs up my channel. Okay. I'll stop. Move that to the left. So I have sine squared x plus sine x equals 0. So this is a way to tackle this problem, guys. So then what you're going to do, you're going to factor out a sine x. So some of you want it to cancel, so don't do that. Factor out the sine x, and then you're going to have sine x plus 1. See? If you do that, you have sine squared plus sine x. Yeah, that sine squared, side note, that sine squared x means that it's sine x, and that sine x is being squared like that. That's what it means. So then I find where sine x is 0, and sine x is 0 on the interval, let's see, here, and here. So I'm actually missing an answer. 0, pi, and 2 pi, because I did put a bracket on 2 pi. So notice none of these have 2 pi, so it should have been, it's a small error, should have been a parenthesis instead of a bracket. So my bad, guys, but it still didn't affect it. Like, I still wanted to see that work. So in case you're thinking, like, why didn't you exempt it, Chavez? Because I still needed to see this right here, guys. So then this, you can go sine x plus 1 equals 0. So that means sine x equals negative 1. And on the unit circle, sine x is negative 1 down here. And that happens at 3 pi over 2. What do you guys think? Not bad, right? Okay. Any questions on that one, guys? All right. What is the amplitude of y equals 5 cosine x? The amplitude is just what? 5. All right, what is the maximum value of the function 15 sine pi x minus 9? Well, this is the midline. And then this is the amplitude. So from negative 9, add 15. And what is that? 6. So there it is. That's the max value. That makes sense, guys? Yeah, because from the midline you go up 15, and from the midline you go down 15. This one doesn't specify radians or degrees, so I took both answers, whatever you gave me. That is your B. So remember that your B is just 2 pi divided by period. If you did it in radians, if it doesn't specify, always do radians. You could also have said 360 divided by period. Some of you gave me both because I didn't specify. That's fine. Whichever one you gave me, I give you full credit. So you can either say 2 pi over 3 or 360 over 3, and you didn't have to simplify, but if you did, you have to simplify correctly. So 360 divided by 3, I guess you don't necessarily need a calculator for that, because you can just do 36 divided by 3, and that's 12, right? 120 degrees. So 2 pi over 3 or 120 degrees. It doesn't matter which one. Yay or nay? Okay. All right, here's what I wanted to see for this. I needed to see some evidence, at least one of them. It says 2 positive and 1 negative that are coterminal to the angle negative 80 degrees. So negative 80 degrees, guys, means that I am down here. There's negative 80. And I want you to give me more angles. So you just go plus 360. So negative 80 plus 360 degrees. So you take your calculator and you go negative 80. And you just add 360. And there it is. There's 1, so 280. And then you take the 280 and you add another 360. So you go, I'm just going to push enter. No, I got to push 360. Excuse me. And I get 640. And there it is, 2 positive ones. Now I want 1 negative because it says 1 negative. So you take the negative 80 and you subtract 360. So you go negative 80 again. And I subtract 360. And there it is, negative 440. So what answer is that? Is it D? Question 10, find the period of the following function. So I know that's your B value, so I know that the period is equal to 2 pi divided by B, because B is equal to 2 pi divided by B, period. So 2 pi divided by 1/4. Keep, change, flip. 2 pi times 4, or 4 over 1, so 8 pi. What do you guys think? Not bad? Okay. Find the phase shift for the following function. So phase shift, so I want it to look like this, guys. Bx minus c close plus d. So you're looking for that. And well, at the moment, it doesn't look like that, guys. So 6 sine, parentheses, notice there's a power over 8 in front of that x. So I'm going to factor out a power over 8. And then I'm going to have x minus, so let's see, if I factor out a power over 8, that means I just have an 8. Close, minus 3. See, if I distribute, that's pi x over 8 minus the pi's cancel out when I distribute, and you would just get pi, which is that. See, so that's correct. So that just means I just move 8 to the right. How do we feel? Not bad, right? Okay. Ooh, this one. I don't know why you guys thought this one was a hard question, guys. It wasn't that bad at all. We're going to go slow. So check it out. No, it's actually not bad. It really isn't. Look, let's go over it. For several hundred years, astronomers have kept track of the number of solar flares or sunspots. Whenever you get a chance, Google sunspots so you can read about this, that occur in the surface of the sun. You see all those little sunspots? And then I guess solar flares are these guys. All right, the things that come out. The number of sunspots in a given year varies periodically from a minimum of about 10 per year. I guess these are the solar flares. That guy, the sunspots or whatever. to a maximum of about 110 per year. Between 1750 and 1948, there were exactly 18 complete cycles. 18 complete cycles. Below is a picture of the sun. Pretty wicked, right? Yeah, I think it's pretty cool. I think it's pretty cool. All right. What is the period of the sunspot cycle? Of a sunspot cycle. Okay. Well, they told me between 1750 and 1948, so I'm going to go 1948 minus 1750. They told me that there were how many cycles? 18. So I take that difference and I'm going to divide by 18, and that's going to tell me how long one cycle takes. Does that make sense, guys? So I take my calculator and I'm going to use the fraction feature. You don't have to. And I'm going to go 1948 minus 1750. 1948 minus 1750. And I'm going to divide that sucker by how many complete cycles there were. There was 18 of them. So there it is. I get a nice pretty number. I get 11. So 11 what? 11 years. So that's how long the period is. It lasts 11 years per sunspot. Yeah, someone Google, whenever you get a chance, Google about sunspots and on the surface of the sun, so you can learn more about it and then fill me in. Maybe I'll Google it myself, because I see like stuff coming out and I see a whole bunch of black. So are they talking about the dots, or are they talking about the stuff that's spewing out? What is the period of the sunspot? When I hear sunspot, I think spots in the sun. So, but they can't be talking about that, right? Or are they talking about the flares that are coming out, the stuff that's coming out? Yeah, someone Google and find out. See, it says astronomers can keep track of the number of solar flares or sunspots. So is it a flare or is it a spot?
That's all I remember. Spots are usually
Yeah.
Oh, because when the flares up, it removes stuff from the sun, so it's like getting cooler, and then it pulls back. So those little dots, those are when that cools down, when it goes back.
But it's still hot though, right?
It's still hot, yeah, but it's not as hot as the rest of the sun.
It is exciting stuff. So cool. All right. Assume that the number of sunspots per year is a sinusoidal function of time, and it is, by the way, if you Google it, if you go to NASA, and that a maximum occurred in 1948. So there's my maximum. Find a particular equation expressing the number of sunspots per year as a function of time. Okay, here we go. I know that I have a max of 110. I'm talking about the number of sunspots. Max, 110 sunspots. And min, what's my min? 10 sunspots. So if that's my max and that's my min, I can find. So here's what I'm doing, guys. In case you're wondering, Chav, what are you doing? I'm doing this. I already know what the C is. The C has to be 1948 because they tell me that's where I have a maximum amount. I already know what the B is. The B is just 2 pi over 11. I need to figure out what the D is. So the midline is just going to be 110 plus 10 divided by 2. So that's 120 divided by 2. That is 60. And the difference between 60 and 110 is 50. So A has to be 50. So there it is, guys. I got everything I need. So find a particular equation. Y equals 50 cosine 2 pi over 11 parenthesis x minus 1948. They didn't tell you that you have a maximum. Some of you put 1750. They don't tell you you have a maximum of 1750, guys. They just tell you that's where they started the period. Close, and then plus 60. Cool or not cool? That's what I'm going to type into my calculator, guys. So type that into your calculator. Y equals. Oh, I'm still in polar mode. Let me function. Clear. Sorry, we have a lot of calculus stuff here. All right, let's see. What do we got? 50 cosine 2 pi over 11. 50 cosine alpha y equals 2 pi over 11. And then move, and then x minus 1948, close. What was it, plus 60? Okay, don't push graph. Not yet, at least. Because I know I'm gonna use it. But that's all they wanted on that one. And then how many sunspots will there be in the year 2026 in this year? Okay, so here's what I'm gonna do. I'm gonna click on Window, and I'm gonna start. Let's see, where do I start it? 2000. And they want all the way to 2026. No, I'm gonna go to 2040. 2045. So I'll see at least 4 complete cycles because each cycle is 11 years. And Y min 0, and Y max, it goes all the way to 110, so I'm going to go to 120. Y scale by 10, and X scale by 5. And then check it out. My calculator is faster than your calculator, but... So what did they want to know? What year? How many sunspots will there be in the year 2026? Okay, so I'm going to push trace 2026. Enter. About 102. 102.0626. So you can put in 2026, comma, there will be about 102 sunspots. All right, and then this year, well, this year we're 2023, and I guess you can make a case for like a decimal, 2023 point whatever for the month, but 2023, 80.77, so maybe 81. This year, 2023, there will be about 81 sunspots. And if you give me a decimal, that's okay for now, guys. Cool or not cool? All right. What is the first year after 2026 in which there will be about 35 sunspots? What is the first year after 2026 in which there will be a maximum? Okay, perfect. So I'm going to change my window. I'm going to start at 2026. And I'm going to go to 2050. And I'm going to click Y equals. What number did it take? 35? So I push graph. I put 35 on Y2. Bam. I find my intersection, my very first one, that guy. So I go second, calculate, number 5, enter, enter, and then when it says guess, scroll to the one you want, enter. So in 2028, you could also say 2029 because of that 0.66. So, and I guess that's just 2028.667. And I'll put here for you guys to discuss 2028 and what month. In 2028, comma, there will be 35 sunspots. And what is the first year after 2026 in which there will be a maximum number of sunspots? Okay, so maximum number, I'm looking for this guy way up there. Do you guys see that? So I tell the calculator, second, calculate, and I'm going to say the word maximum, number 4. And it tells me, where do I look? Left bound. So I'm just going to go right here. I push enter. Right bound. Look between what and what. So I'm going to go to the right and go a little more. Enter. Guess. No. Boom. Right there. And 2035.9998. So you can just say 2036. In 2036, there will be a max number of sunspots. All right. What do you guys think of that question? Was it tough? Or was it okay? All right. I'm telling you guys, you're going to see it again. We only have another 2 weeks when we come back from Turkey Week. You're going to see this question in some way, shape, or form on the semester exam. Don't. It's okay, Sanchez. Relax. Yeah, that's the third yawn. That deserves a demerit. All right. Question 13. And we're pretty much done. Okay, here we go. Particular equation of the sinusoid. You can use cosine. Okay. So y equals a cosine b parenthesis x minus c close plus d. And we're in radians. So let's see. The midline, I guess let's first find the midline. D equals the max is 7. And the min is -3. And I'm going to divide that sucker by 2. 7 plus -3 is 4. And 4 divided by 2 is 2. Now that I got the midline, I can get the a by just going 7 minus 2, which is 5. And then the b comes from 2 pi divided by period. Well, the period, peak to peak, that one's at 3 and that one's at 23. So the difference between 23 and 3 is 20, so that's the period. So 2 pi divided by 20, so it's pi over 10. And then the c, I can use whatever c I want, either the 3 or 23. I'm going to use the 3, and there it is. I got everything, guys. Y equals 5 cosine pi over 10. I don't see any mistakes. X minus 3 close plus 2. And that's it. Cool or not cool? It says find graphically with a calculator the x value shown in the indicated y value. I wanted to hit y equals 6. So type this guy into your y1. And in y2 type in 6. So here we go. So on y1 I'm going to type in, let me clear this and clear this. And I already forgot. What was it, guys? Yeah, help me out. 5 cosine pi over 10 x minus 3 close and then plus 2. And then on the other one I put 6. And then I'm going to make it look exactly like this. So my x min, 1, 2, 3, -3. So click on window. And I'm putting -3. X max, 23, 24, 25, 26, 27, 28, 29. Go all the way to 29. X scale by 1. Y min, it looks like -4. Y max, let's see, what do we got here? 7, so I'm going to go up a little bit more. 8. And Y scale by 1. And there it is, guys. It looks exactly like that. Cool, no? And then I just find the intersection, guys. Second, calculate. Number 5. Enter, and then guess. So you scroll to the first one. And I push enter. So someone write that one down. 0.95167. X equals 0.95167, comma. And then I'm going to get the other ones. Second, calculate. Number 5. Enter. 5.0483. 5.0483, comma. Second, calculate. Number 5. Enter. And I'm just getting the others. Enter. 20.9516 or 17. 20.9516. That's truncated or rounded. Yeah, I probably should have used 17. That's fine. Second, calculate. 5. Enter. And then finally, 25.0483. There it is. What you guys think? All right, last one. Find the x values algebraically. At minimum, find the expressions that will get me all the solutions. Okay, here we go. You get 1 point if you did this. So I'm going to write 5 cosine pi over 10 x minus 3 close plus 2 equals 6. If you did that, you got a point automatically. All right, next. What's my first move? What's my first move, guys? Yeah, subtract the 2. Minus 2 minus 2. 5 cosine pi over 10 x minus 3 close equals 4. What's my next move? Divide by 5. So cosine pi over 10 x minus 3 close equals 4/5. What's the next move? Did you guys say arc cosine? Yeah, arc cosine. Plus minus arc cosine of 4/5 plus 2 pi n. I'm going to start writing over here. The next move is multiplied by the reciprocal of 10 over pi. So you're going to have x minus 3 equals 10 over pi plus minus arc cosine of 4/5 plus 2 pi n. So when I do that, and I'm going to move that 3 right in front, x equals 3 plus minus 10 over pi arc cosine of 4/5 plus, let's see, 10 times 2 is 20. The pi's cancel out. 20n. That should not surprise you because that's what the period is. So x1 equals, I take my calculator and I do the 3 plus and then I do the 3 minus. So let's see. Second quit. 3 plus alpha y equals, enter, what was it? 10 over pi or pi over 10? 10 over pi. And then second arc cosine, it was 4/5, right? So there it is. I push enter. And 5.0483. That better be one of the answers. Yep, it's that one right there. 5.0483 plus 20n. x2. Now I'm going to subtract. So I just scroll up. Enter, and instead of a plus, I put a what? Minus. And again, you better get one of the answers, 0.95167. And sure enough, it's that one right there. 0.95167 and 20n. And yep, that will get you both answers, because if you add 20, that will get you that one. And if you add 20 to the 0.95, that will get you this one. Plus 20 plus 20. And there it is, guys. So we did all the exam in about, let's see, 9:10. So that took us, what, 40 minutes? 40 minutes to talk about the exam with explanations and everything. So what do you guys think? Now that we've gone over it, was it a fair exam? Yeah. Have we covered everything in this test? We have, guys. We covered everything. So, okay. Take care of your delta. You'll get half your credit back. The delta is due before you leave for Turkey for Gobble Gobble. And that's it, guys. Subscribe to my channel if you haven't subscribed, and give it a thumbs up. Well, you can give it a thumbs down if you want. All right, later, guys. Bye.